Hello everyone, in this revision tutorial I am going to show you how to perform the Floyd-Warshall algorithm. So to start off with, we need to complete a table showing the initial possible distances between each node. So I'm first going to put the slashes here just to show that we cannot connect the nodes to themselves. Okay, so first we're going to try and find the simplest possible route from A to B, and we can see that it's 10. So if there is an arc between them, we write down the number, and if not, then we write down infinity. So A to C, you can see this long arc here, which is 5. Then A to D, we cannot go from A to D because this is one way, so we're going to put the infinity symbol here. B to A, 10. B to C, 3. B to D, 7. C to A, 5. Remember, it's row first and then column, so it's row to column, C to A. And now C to B is 3. C to D is 11. And D to A is 1. And we can go this way because the arrow is in that direction. D to B is 7. D to C is 11. And now, so far we have only found our initial possible distances, so we're going to complete the route table now. So in order to get from A to A, it's via A to B is B. We're just making this as simple as possible. I'm going to explain how this works later, but just fill this in with A, B, C, D. So A, B, C, D on each row. Okay, so now we are going to see if there are quicker routes via all of the vertices. So we're first going to see if there is a quicker route via A, and I'm just going to explain to you how this is going to work now. So we now need to rewrite our tables. Okay, so we are going to, because we are going to find routes via A, we first are going to write down the same numbers as in column A and row A. So just put dash 10, 5, and we are just going to now highlight this. Okay, so the way that this is going to work is that you look in a certain field and you're going to see if there's a quick route via A, so you add these two numbers, and if the sum of the numbers in the same row and same column is less than the previous number, then you update it with the smaller number. So we can see that if we were to go from B to C via A, then the length of the route would be 10 plus 5, which is 15, but we've got 3, and that's better, so we're just going to put 3 here. Now, B to D, 10 plus infinity, that is definitely greater than 7, so we're going to leave 7 here. C to B, no, 3. C to D, 11 is smaller than 5 plus infinity, of course. Now, D to B, 10 plus 1 is 11, no, 7 is smaller, I'm just going to put that in here. And D to C, 5 over 1 is 6. Oh, that is better, so because 6 is less than 11, so we just realised we found a quicker route via A, so we're just going to put 6 here. Now, whenever we find a quicker route via a certain vertex, we're just going to update it here because we just found that there's a quick route via A. So if you want to go from D to C, you have to put A here, and we're just going to underline it to show that it's changed. Okay, so we are just going to copy everything down from here, what hasn't changed. And then we copy the tables again. We are now going to copy the b's into here. So now we're just gonna find the roots via b. So 10 plus 3 is 13, no, 5 is better. 10 plus 7 is 17, now 17 is less than infinity, so that is better, so we put it here. 10 plus 3 is 13. 3 plus 7 is 10, 10 is less than 11, so we put 10 here because it's better. 5 plus 7 is 12, no, 1 is better. 7 plus 3 is 10, no, 6 is better. Okay, so our distance table is now complete, and so the changes that we've made here, 17 and 10, so this means that the better roots are via b, so we are going to put b here and underline it. And then we just copy the previous table into here for the values which are still blank. Okay, so we are now going to go via c. So 5 plus 3 is 8, so 5 plus 10 is 15, and 15 is less than 17, so we're going to put that there, which proves it. Well, 5 plus 3 is 8, and 8 is less than 10. Okay, 3 plus 1 is 13, no, 7 is better, and 5 plus 6 is 11, no, 1 is better. 3 plus 6 is 9, no, 7 is better. Okay, so our table for distance is now done, so we're now going to put C here from A to D, because in order to get the best route we need to go via C, and we just copy down our previous table. Okay then, so we copy down D as it is in this table. 15 plus 7 is 22, no, 8 is better. 15 plus 6 is 21, 5, okay. 8, it's the same really. Yeah, we're not going to mark it as changed. 7 plus 6 is 13, no, 3 is better. 11, no, 5, 17, no, 3. And so our distance table is now complete. So there are really no changes, but I'm just going to copy this down just to show you that this is the final table. Okay, so now I am going to explain to you a bit how to use this table. So if you ever get asked a question in the exam, a question which requires you to find the shortest route using the table you've just got, then for example I want to find the shortest route between A and D. So to start off with, we're going to write down A dash D, and the dash shows that we may have a vertex in between these two end vertices in our quickest route. So by looking at this diagram here, if we see A to D, we need to go via C. So we're just going to show that C is going to be within our route, so A dash C dash D. Now, in order to go from A to C, we can go straight to C, so it's A, comma, C, and then to D. And in order to go from C to D, we need to go via B. So we're going to write down A, comma, C dash B dash D. So now, in order to go from C to B, we can go straight via B. So A dash C, and then B to D. So this shows us that from A we can go straight to C and then straight to B, because the commas say that you can go straight to those in the route, but the dashes show that you may have vertices in between. So in order to go from B to D, we can see that we can go straight to D. So A, comma, C, comma, B, comma, D. So we don't have any more dashes, so we can see that the shortest route from A to D is A, C, B, D, and to find its length you just look at your distance table. So A to D is 15, so the length of the route is 15. And that is how you use the Floyd-Warshall algorithm to find all of the possible shortest routes between every pair of vertices, and also how you can use your route table to find the vertices in your shortest route. So I hope you enjoyed this video and found it helpful. So please consider liking or even subscribing if you want to be notified of future videos. Goodbye.